everyone. Once again, it is your boy Christian Schuster, the firmware lead for this year. And today we're going to be tackling a topic called registers. And this is a very important topic because it kind of gets down to the nitty gritty of what firmware really is and in the ways that it kind of differs from software. If you think about software as, your 3-question long answer, physics exam, where it's a little more open-ended. You're kind of like trying to think of like what you know and just trying to take what you know and answer these questions. And then if you think of firmware as more of this 100, 200 question true or false exam, and it's an open note exam, except your open notes is like an 800-page textbook. That's kind of more what firmware is like, where software is kind of, big part of it is you figuring out, and then firmware, a big part of it is you have a bunch of yes or no questions that you need to answer, and you just need to go through all of them, and you need to answer them all correctly. That's kind of what gets into registers. What you have to remember is that computers work in a way of ones and zeros. All they're doing is asking themselves a bunch of yes or no questions, essentially, or using ones and zeros to make numbers and stuff like that. But basically, it's just a bunch of yes or no questions. And when you're doing firmware, you're actually the one answering those yes or no questions, because when you're doing it for an embedded system, for a small microcontroller, they're not going to have this nice GUI for you to click on things and do that kind of computation for you. You need to tell them whether yes or no you want this thing in the code. You can't you don't get to click buttons on a screen or anything like that. So as we get into it, I made a little sheet here as an example. So let's say we had a heat motion sensor, all right, and we had a register here of 0x00. So this is like kind of where this the address for where this information is for this device. And let's say we were able to send 8 bits of data to this device, and each of those 8 bits did something else. And if one of those bits is 0, then basically it's just ignored. But let's say we wanted to use this heat and motion sensor. So obviously we would need to put a 1 there and enable the whole system. And basically, let's say we wanted to only use the heat sensor, so we put a 1 at the heat sensor and put a 0 into the motion sensor. And then let's say we wanted it to send out a high signal for a second. This is called an interrupt, or high or low signal depending. But let's say we wanted to send out a signal once it reached a certain temperature. This is obviously very important if, we have a heat sensor on our battery and it reaches over the threshold of what we consider safe. We wanted to send out an interrupt and say, hey, shut off the whole machine. So let's say we want to do that. Let's say we don't actually care. This is like communication. Let's say we don't really care what the temperature is, except for if it goes over that threshold. So we actually don't really need to be communicating. And then this is just like fine tuning stuff. I just had these to fill in the extra space. Let's say we wanted high sensitivity, and then so we don't really care about the rest of these guys. And so that means that basically the way that you're coding this is that you're sending quite literally binary, just a binary byte of data to one of these devices, and you're telling it what to do. When you first open up some of the code that we have, it's going to be all these lines and lines of code. It's going to be so overwhelming. But if you actually read into what's going on and look at it, you realize, hey, they're basically just saying at this point to turn the device on. And at this point, they're trying to configure the device to do what they want. And if you go into the data sheet of these devices, for example, right here, they have a huge list with very well written out documentation of what every register does. You're going to go through and pick and choose what registers you want to use. And then you just write the bits or bytes to those registers in order to use them properly. So that's kind of the first example of, okay, you just got one device you're writing to, or more like one address that you're writing to. But let's say you got Bluetooth earbuds, all right? And let's say that this earbuds, they have actually 2 addresses that you can write data to. First address is going to be kind of your more just kind of, again, binary information. The next address is your volume address. So if the user's adjusting the volume, what's happening at that address. So again, we want to enable Bluetooth probably because we want to be able to connect to it. And then let's say Want to make sure that Bluetooth is connected, and so we'll get to that in a second. We want to have that bass boosted, baby, of course, because otherwise, like, what are you even doing if you aren't listening to it with the bass boosted? You don't want water damage. That's more of like it's sensing if there's water damage. Let's say you have low battery, so that means you're probably gonna have a red LED, and then you're not gonna have a green or blue LED. And again, it's simpler when you get down to this level, but it is a lot of information that you need to do. Like, just to very basically configure your Bluetooth earbud, you had to ask yourself 8 yes or no questions basically every single time, and that's kind of what the computer is doing. And the more that you can make your brain think like a low-level computer, the better. And so let's say we're trying to go to this next address that's also a part of these Bluetooth earbuds. So, and that's the volume, you know? So you obviously don't want it to be too loud, so we're not gonna fill it up all the way, but let's say, oops. Let's say want a good solid medium volume here. And what would be different between these two is that this first one, it's kind of each individual one is answering an individual question, right? Like this first one is saying, okay, I enable Bluetooth. Whereas for this volume one, these are more of like being summed together, you know? If you did 1 0 0 0 0 0, that wouldn't actually be the loudest. The loudest would be 1 1 1 1 1. Or in this case, it's not like just this bit that matters. It's that this bit plus this bit plus this bit plus this bit gives you the total volume of what you need. And what this kind of looks like very generally in firmware is basically the first thing you do when you're using a device is you write out the function that allows you to write data to that device. And in all these examples, we just did 8 bits or 1 byte of data. So basically what we're going to say is that what our function kind of looks like with its parameters is that you write 8 bits of data. It says first is the register is where are you writing this data to, the address. Like, and for example, for this one, for the Bluetooth earbuds, this first one would be kind of the settings register, the 00, and the second one would be the volume register, which would be 01. And then the next parameter would be the actual data of what you want to send it. And so then if we were doing, for an example, or if we write to the volume register, we do half the bits full, boom, we have medium volume, like perfectly in the center. Another thing that you can do with these registers, as I'm talking mostly about writing here, but that's just because it's simpler to think about, is you also read values from these registers. And it's also something the device is doing. So if you want to be checking to see if there's water damage on your device, and you'd be reading every once in a while, hey, is there water damage right now? So let's say we have a true or false of water damage, and let's say that if we want to see if water damage is a 1, and if it's a 1, then it's true. So we do data read instead of data write, and then we'd read from that first register, and then we would have 001 0000, and that's all in binary to kind of see, okay, is it water damaged? And if water damage is true, then you want to, like, in some way say, hey, there's water damage. Obviously on a Bluetooth earbud, it'd be more something like this, but, you know, I decided to make it a little more fun. Like, oh, jeepers, like, why'd you drop me into a puddle? Because obviously you just hurt your earbuds, and that really sucks. I hope this was helpful. I hope you all are doing very, very well, and have a great day.
I also realized that I made an oopsie in this video, and in C, actually, you don't put a B there for binary. You do 0B in the beginning for binary. If you're trying to do this like actual example code, a lot of times in some data sheets, you'll see B at the end to signify binary, but an actual C would be 0B, and then these registers here is 0x is for hexadecimal. So that is my bad. For those of you that caught that, bonus points. You're doing great.